Ladies and gentlemen, thank you for your time and patience during these sessions. And in the last, I want to invite Dr. Adresi, who his research in the field of concrete pavement and concrete materials is very interesting for me, myself, and surely for other researchers in the field of concrete technology. I want to yeah, I want to invite Dr. Adresi for his presentation. Thank you.
Hello, everybody. Thank you for your attendance and your patience up to this time. In the name of God, I want to start my presentation in subject of structural health monitoring. At the first, it is my duty to, it's my important to pay tribute to the passing of my esteemed Professor Dr. Awal Fazle Hassani, who departed last week, next Wednesday, and may the rest in peace. He was my lovely professor in PhD. I offer my condolence to all colleagues and the scientific committee for these huge losses. Okay, the subject referred to pavement structural health monitoring based on self-sensing concrete sensor. In this presentation, we focus on these titles: structural health monitoring, principle of self-sensing, literature review in this area, and self-sensing based fatigue model, also self-sensing based remaining life model, which is key point in structural health monitoring of the pavement. As you know, structural health monitoring over time, the most concrete structures deteriorate and get damaged due to the environmental and external loads. In order to identify defects that may eventually threaten the health of a structure or lead to its failure, the condition and health of a structure should be monitored over time. The term of structural health monitoring refers to process of identifying and diagnosing damage in engineering structure. In this regard, okay. Okay, the next. This is the pavement structural health monitoring. Currently, the methods of assessing damage to different types of pavement include the following steps. Number one, road segmentation. As you can see the above picture, the first of all, we define a segmentation in roads, number one up to N, and monitoring the condition of the pavement, including visual flaws such as different types of cracks, potholes, and so on, and riding quality by some commercial instrument brands, as you can see in the left picture, ARAN. Also in the middle picture, you can see the instrument for structural adequacy which is called falling weight deflectometer. The weight drop on a pavement and the response measure, and by back calculation we calculate the stiffness of the layer. Also skidding levels in right picture, the instrument called mu-meter measure the skidding of the pavement, is referred to safety, driving safety. these data are gathered over time by conducting periodical test step for a specific pavement length and location. Number two, data gathering and transforming each pavement section. And number three, data analysis. Number four, in structural health monitoring of pavement, determining the current state of pavement condition based on analyzing and processing of extracted characteristics. For example, PCI, Pavement Condition Index, is one of the index show us the condition of the deterioration in the pavement. 100 means no, the condition rate from 0 to 100. 100, we didn't see any defects, and when we go forward to 0, means the condition of the pavement is worse and worse. So when we gather the data from the pavement and calibrate a model, okay, number 5, start prediction of remaining life based on pavement life models. When we define some threshold, for example, 70 or 55 here, and we reach this threshold, we decide number 6, finding the right maintenance option at the right time and place that will minimize the life of the pavement while maximize the life of the pavement while incurring the lowest cost. Means that we searching for proper maintenance action. Current method challenges. Our previous method, mentioned pavement condition evaluation methods are periodic. That nature of discrete measure will generate some errors such as device error, different operator performance, differences in pavement condition, and so on, and also approximate location of the test in different time interval, causing error in data collection process. So what is the solution? The solution is changing this type of data gathering by converting the pavement to a sensor. Means we change the material of the pavement to the sensor. It's not specific for in a pavement. You can change the material of a structure to the sensor. So we change the pavement to the sensor, gathering the data and using this data to performance model and structural health monitoring for pavement is the start. Okay, there are a lot of sensors for using in structural health monitoring, but which one is better? Which one is cheap? Which one is durable? Which one is sensitive? We must search about, if we want to operate and come some technology to real field, we must think and find the solution for most durable and cheap, affordable solution. This is the self-sensing concrete sensor is the solution. What is the self-sensing sensor? The concrete adding functional filler, a conductive filler to the concrete or asphalt or masonry material, change it to smart materials. Means by applying force, humidity, temperature to this material, the response of that material, which is electrical resistance, change. And this type of sensor can work for us for crack detection, stress strain monitoring, microstructure study. One of my students now is working on this subject, means correlating mechanical fracture mechanic models to the output of the sensors, electrical output of the sensor. Another one, traffic monitoring, and so on. So we can, maybe you have a question, how this type of sensors work? This is your answer. Sensing mechanism. What is the sensing mechanism? When you add some conductive filler to this media, the concrete media, a concrete pad is creating. The concrete pad helps the electricity current move in the area of the concrete. And when you push the concrete, the distance between these conductive filler decrease, and the electron can easily jump from this conductive filler to that conductive filler. So we have a correlation between pressure and electrical resistance change. So this is the base of sensor. Also in damage detection, assume that a lot of conductive filler here in this picture. There is a lot of conductive. There are a lot of conductive paths in this filler. When you cut some this conductive path, the resistivity change. So the crack can change the resistivity. Okay, literature review. This is for maybe your question. Is this a novel idea or work in the field? You can find out its work in a real form. In this picture, the concrete sensor was placed in the small column. The finding indicate that the stress applied on the sensor increased the electrical resistance of the concrete sensor, decreased. It was observed that there is a direct correlation between the stress and the strain of the concrete sensor with its electrical variation. And an example of traffic monitoring. Using an example of traffic monitoring, Hahn et al. Embedded a concrete sensor in a pavement and measured the variation in electrical resistance of self-sensing CNT cement composite under different vehicular loading. Figure A, the above figure, show two middle-sized vehicle pass over the sensor. Figure B at the bottom shows minivan pass over the sensor. So this sensor can detect the wheel passed. Another one, weight in motion, means that Albertini developed a self-sensing sensor slab in a pavement at the field study before and after the breach. They were able to weight the traffic loads in motion by weight of each axle and use the gathered data to monitor the health of bridge structure. In a steel structure health monitoring, Hahn et al. Successfully captured a structure's behavior under variation loads by incorporating concrete sensor with self-sensing capabilities into a building model with a steel structure. The comparison with conventional electromechanical strain gauge and force gauge sensor demonstrate a superior accuracy of concrete sensors. Smart bricks for masonry structural health monitoring. Albertini et al. Successfully developed a smart bricks technology with self-sensing capability by incorporating conductive filler into soil material and change it to a smart bricks. These bricks were integrated into a traditional structure to create a sensor network through a monitoring of sensor data the researcher could accurately identify the formation and propagation of cracks in historic building in Perugia, Italy. Damage detection based on skin sensing. Another method for damage detection involves utilize the electrical impedance tomography, EIT technique. This technique entails positioning a series of electrodes on a surface of possesses self-sensing capabilities. Each electrode takes turn transmitting an electrical pulse, which is then picked up by remaining electrode. This sequence is carried out systematically for every electrode. When a crack is occur, the time of the time of the moving electron between these two electrodes change before and after cracking by analyzing based on tomography technique models the damage localization and the damage propagation can be shown, can be demonstrated in this picture. Another work, damage detection based on ERT, was applied by Sumit and Sumit Gupta in California, I think. They try to validate large-scale application of self-sensing concrete in airport runway and runway pavement, and to use electrical resistant tomography (ERT) for characterization, especially distributed damage during accelerated pavement testing. As you can see, the above picture A, this is a sensing sensors. They cast some sensor in a field test and move a heavy load in accelerated testing facilities, and in result they can find out that in picture at different levels of passing the vehicle, passing the wheels from 9,000 up to 16,000 or to 70,000, a crack occur and the crack propagates. And this type of sensor can find out the crack and localize it. Okay, the base structural health monitoring based on self-sensing ability. The region of pavement failures.
You have 2 minutes left.
2 minutes, okay. A summary. If you want to generate a structural health monitoring, you should generate a model, use the electrical response of the sensor, and predict the remaining life of the pavement. When you know the remaining life of the pavement, you can manage a proper maintenance action. Okay, in this research study, we analyze the concrete sensor fatigue performance. We put a sensor in a beam and we run a fatigue test. We generate SN curve. Also, we interpret sensor behavior under electrical sensor output under fatigue loading. We find out a slope of the response of sensor in their life change. And we define a G factor, which is a damage per cycle, and a Goodman curve. Rewrite as this new type of fatigue model, which is log G log N instead of S log N. And we use this type of fatigue model to predict the remaining life of the pavement by substitute that model in the equation in first line. We have remaining life, and we extend the use of this model in different loading condition and loading amplitude, and we finally we generate the remaining life of the pavement based on electrical resistance of the sensor in the last equation. Thank you very much, and thank you for your patience.
Okay, we can have one question from the floor. If there is any question, you can raise your hand. Okay, there is a question.
Well, first of all, thank you for a great presentation. I just wanted to ask a question about the
Please loudly.
Loudly, all right, okay. Okay, I want to ask a question about the feasibility of this kind of materials right now. For example, okay, another time. Okay, now I think now it's better, right? Okay, well, I wanted to ask a question about the feasibility of these self-sensing materials. I want to know, is it really worth it, for example, considering the fact that right now in countries like Iran, for example, asphalt pavements are almost free. I want to know about the cost of using these self-sensing materials. If I understood well, for example, they contain carbon fibers and so. And you said that this is the best approach. I want to know it from the financial point of view. Is it really worth it? In Iran, or I don't know, maybe in another countries, maybe the conditions are different. Okay, thank you.
About the feasibility study of this type of sensor, we work on multiple carbon nanotube to casting this type of sensor. But now we are working on byproduct of different conductive filler, which is byproduct of industries such as iron and copper slag, iron slag, and we find out that also the sensor works with that type of the conductive filler. Exactly, we don't want to change a whole slab, of the pavement or one slab to a sensor. We cast a small sensor and put in a critical area, and this is another work we are working with Professor Lavasani here to know that when we have a limited sensor in a slab, how we can find out where is the crack and how we find out the crack severity in this case. Thank you.